Okay, well, I'm going to go ahead and get this started. Again, I'd like to welcome everyone to today's session. My name is Mason Myers. I am a Moldflow engineer with Autodesk. Today, I would like to talk to you about Moldflow Insight, in particular, how we talk about a quick start in order to get you up to speed with Moldflow Insight. This is geared towards new users that may have just purchased the software, or maybe you're looking to get some additional insight into some tips or tricks. We do provide on-site training that's a little bit more in depth, but this would give you a feel for what's entailed with that particular on-site training. With me joining today, I do have my partner in crime, one Tim Van Est. Tim's going to be helping me manning the questions. As I mentioned, all attendees are in listen-only mode for this. I would encourage you to use the chat or the questions box in order to ask questions throughout the presentation. I will open this up to questions at the end of the session, as well as providing you our email address. So if you have direct questions that you would like to email us, you can do so at that time. So with that, we'll go ahead and get this started. As far as the outline for my presentation today, I'm going to be doing a little bit of back and forth between PowerPoint and in software. I'm going to take each segment and talk about it in PowerPoint and then follow that up with an in-software demonstration. I'm going to start off by talking about the user interface of Moldflow Insight, as well as how to import a model. We'll talk about the different mesh types and how to do some cleanup of meshing. I'm then going to talk about some basic process setup with Moldflow Insight, as well as results interpretation. We can finish that up with how to reach us, as well as I mentioned, opening this up to questions and answers. So again, I see some familiar names, so I think some people may have attended a Moldflow Advisor Quick Start that I presented yesterday afternoon. Today's going to be focused on Moldflow Insight, as I mentioned. So big picture, think of Moldflow Advisor as like a directional compass, where Moldflow Insight, we're starting to get a little bit more granular. We have a little bit more knobs to turn. We can do some more complex analyses. But regardless if we're using Moldflow Advisor, Moldflow Insight, I do have a list of questions here that are important. All of these questions can be answered through running a simulation, whether that be thermoplastic or thermoset materials. But what Tim and I teach in the training is if we can narrow this list down to a few questions, it could help us guide ourselves through the analysis workflow that we may need to do in order to solve these. For example, will the part fill? How many gates are required? Are there air traps? Are there weld lines? That's something that could be answered through either a gate location analysis or maybe a simple fill analysis. If we start getting down here where we're talking about is the cooling ideal or uniform and will the part warp within my tolerance, that's a different workflow. Obviously, cooling related questions, we may need to run a cooling analysis. Also with warp, if we have specific warp questions, those could be answered through a warpage analysis. Again, so when someone says, can you run a Moldflow on that? Sure, I'd be happy to run a Moldflow on that. But if you have specific questions, the outputs from the software can be a little bit more clear if you have that distinct goal in mind of when you start running a Moldflow analysis. So as I mentioned, the first topic on the agenda is user interface and model importation. If you are fortunate enough to have the software, you can open the software either through one of the desktop icons that were automatically installed when you installed the software. As I mentioned, I'm going to be focusing on the Moldflow Insight product line, and that's going to be the orange M with the small I in the lower right-hand corner. You can also access the software from the Start menu, again, if you have that installed on your machine. Some of you may be up to speed in regards to Moldflow Insight. You may be aware of the differences between Moldflow Insight and Synergy. Essentially, Moldflow Insight is the solver behind the scenes, whereas Synergy is more like the user interface. Now, we still have the same pre and post processor, if you will, you're really only going to be working in Synergy or the user interface. Just be mindful that when you press solve or start analyses, it's actually going to be pulling the insight solver, crunching the numbers, and then bringing the results back to Synergy. The reason why they are separated is that we can have multiple synergies installed at your facility that would allow users to do some of the model importation, mesh cleanup, analysis setup, and then solve when that's ideal. So again, different flavors of insight solvers as well. We have standard, premium, and ultimate, and different functionalities are available with the different flavors of Moldflow Insight Solver. But big picture, we're going to be working within the same user interface when we're importing a model, meshing it, setting up a job, building runners, cooling channels, solve it to the solver, and then it comes back to Synergy so we can diagnose the results. As you can see, I've broken down the user interface into multiple segments. The main display window, as you can see, that's where I have my 2-cavity GPS cover. Again, this is where we would see our CAD body that we import, as well as working with the mesh and looking at the specific results. So a lot of magic is happening in that main display window. Before we get to reviewing results, we may be needing to use some of the other sections of the user interface. If you look in the upper left-hand corner, we have our project pane. Think of this like our model tree. If you're familiar with CAD, you'll notice that I have a project created called Quick Start 2018. And then within that project, I have multiple studies. I've got some meshing studies there. I have got a couple gate location studies. I've got a molding window, and then I also have a cool fill pack warp. So I can have multiple studies within a given project. Me personally, I like to keep my studies in my project somewhat clean. So if I have a different part model, I tend to start a new project, but you can have multiple different CAD bodies in the same project if you were so inclined. Underneath the project panel, I have my study tasks. We'll see when we get to some of the process setup. There's some shortcut keys that we can do, such as picking a material, an injection location, setting up some of our process parameters. But really, the main time that you have to use the study tasks is when we solve a job and we start diagnosing the results. You can see there that all of my results are located in the study tasks pane. Below that, we have our layers panel, or our layers pane rather. This is just a kind of a housekeeping issue. So contained within the layers, I can have my CAD bodies that I bring in. If I'm working with an assembly, those will come in cleanly on their own layers. So when we go to mesh the part, all of my elements and nodes, or tetras and nodes, will be contained on those separate layers driven by the CAD assembly. Also, you'll notice I have a geometry tab. So I have slightly advanced topics such as runner systems and cooling channels. Those are also contained within the layers pane. We can turn these layers on and off depending on what we are doing within the software. So if we're modeling runners or cooling channels, we may want to have those layers turned on. If we're viewing results that are not cooling channel specific, maybe we want to turn our cooling channels off, as I've shown in this particular example. Underneath the display window, I have my log files. Again, very much like Advisor, we can uncheck or check the log files here. A lot of good information occurs within the log files. Any of our warning or error messages would populate here, along with some additional information on projected area, some of our setup, things of that nature. On the right-hand side, I have my study notes or plot notes. Again, this is a good best practice. Unfortunately, I don't use this as often as I should, but I can put in study notes or plot notes depending on what I'm looking at as to what I see as an analyst. So when I share these results, maybe with a part designer or a process engineer, they can see exactly what I'm seeing in terms of this particular analysis. In terms of CAD files that can be accepted by Moldflow, you'll notice that we do have a wide range of CAD files that we can import into Moldflow, as well as some files that are meshed from an external mesher. My advice to you is that you start with either native CAD or STEP. Those are my go-to CAD formats coming into Moldflow Insight. If you do use an external mesher, that's fine. We can accept those as well. I will tell you that in recent years, we have made vast improvements to our meshing technology. So if you're familiar with Moldflow Mesher back in the day, 10 years ago, I would encourage you to give our new mesher a shot. It can be very clean to bring in single parts or assemblies. Meshing is almost automatic at this point, so we don't have those hour-long mesh cleanup requirements that we used to have in days gone by. In terms of importing a CAD geometry, it's pretty simple. We're just going to use the import icon that's either located in the quick access toolbar up top, or you can find that on the home tab, and then just navigate to the folder location of your CAD body, and then click on the file and click open, and it's pretty bulletproof at that point. After we select the file, the next thing that's going to pop up is this import wizard, if you will, and it's going to allow you to select your mesh type. Now, I'll explain what the different mesh types are in the different section. Really, there's three main mesh types that we can work with: mid-plane, dual domain, and 3D. But here you can select which mesh type you would like to utilize on that particular CAD body. And I'll go into that a little bit greater detail as far as what I suggest to new users. As I mentioned, Moldflow Insight now works well with assemblies. We can bring in an assembly. So if we're trying to do an overmolding or two-shot application, or maybe we want to bring our mold plates or mold inserts into the analyses, you'll notice that in the layers panel, as I mentioned, we'll have a CAD geometry folder that will have the plastic or thermoset part that we would like to analyze, as well as the other components of that particular assembly. Model orientation is pretty critical. So when we import a model from our native CAD or a step file, it is going to default to the orientation or the axes from your native CAD. That may be okay, but what I'm trying to get at here is we do have a preferred Moldflow orientation. Primarily, we would want the mold open to be in the positive Z direction. The reason why this is so important is that certain plots, such as clamp force, will not be accurate if the model is not oriented in this proper position. Again, we kind of assume that the XY plane, if you will, is the parting plane of the tool, and then obviously the clamp force calculation would be taken off of that particular plane. So that's about the only plot that would be inaccurate if you did not orient the model correctly. Much like Advisor, we do have the opportunity to go into our Geometry tab, Utilities, and we can move or rotate that CAD body to ensure that it is in the proper orientation for our clamp tonnage values. All right, I'm going to jump into the software here, and we are going to take a look again at the user interface, as well as briefly show you how to import a model. Again, I would encourage you that if you have questions during this, please type them in the questions box, and my colleague Tim will help answer those as I'm moving right along. So as I mentioned, the main display window kind of here, that's where you can see my GPS cover that has already been meshed. I have my project pane up here where I kind of have my model tree of the various studies that I've already run on this particular job. Below that, I do have my study tasks. Again, I do use some of these shortcut keys to set my analysis sequence, to pick a material, set my process settings. Please note that you can also do that from the environment toolbar. So if we look up top here to the home tab, if you will, very similar to the study tasks, it kind of walks you through left to right how to import a model, create some additional geometry such as runners or cooling channels, pick a material, our analysis sequence, our injection locations, solve the job, look at results, and then create a report. So that is a very nice workflow for new users, just trying to get up to speed with the ideal workflow for Moldflow Insight. Below my study tasks, I have my layers pane, as I mentioned before. I can easily turn off my nodes, for example. I can turn on my CAD body. Again, it's just kind of a housekeeping thing to keep these different components on their own layer. So if we do have to utilize some visual changes, it's quick and easy for us to turn those on and off. In the lower right-hand corner of my display, you'll notice I kind of have my orientation axes. In this particular case, the CAD geometry was in the correct mold flow position. You can see that the positive Z, or my mold open direction, is correct. Had it not been the case, I could easily go up to geometry, move, rotate, and I can rotate the CAD body, the mesh, the nodes, whatever I need to do in order to get that in the proper mold flow orientation position. If you used any other type of Autodesk products in the past, much like Inventor, you may notice the view cube. The view cube can be your friend once you get used to this. There's no real going back. You can click on different faces of this view cube to get you into a distinct orientation. It can be nice when you're selecting different components or things of that nature. So the view cube can be your friend once you kind of get used to dealing with that. I do have a navigation toolbar on the right-hand side of the display window. All of these features you can turn on and off at your preference. If we go to View User Interface, you'll notice that I have a drop-down of things that I can turn on. For example, right now I do not have my Notes panel turned on. If I were to check this box, I would get those to populate. Some things that I didn't mention in the PowerPoint. The application menu can also be your friend. Now, there's nothing spelled out that says application menu. When I say application menu, I'm referring to this orange M in the upper left-hand corner of my screen. But if I click on this orange M, this application window will pop up, and this is where we can create a new project. We can open an existing project. We can do save, export, things of that nature. If you notice, I did click on the options button there. The options button will allow us to kind of customize the user interface to our liking. First and foremost, if you are new to Moldflow, you can click on the mouse tab and change the mouse commands to be that of your native CAD or whatever is most familiar to you. This is the way I currently use my mouse settings. So no right answer here, just kind of use what's you're most familiar to. One thing that some people often are unaware of that can be helpful is that I can apply a secondary unit system. So if you work in English or metric or both, you can actually apply a second unit system. So when we look at things like warpage, deflection, both millimeters and inches would be displayed on the screen. Also, we can add and remove the plots that are shown with the different analysis sequences that we have populated. So if there are plots that we rarely look at, you can remove those. Wouldn't really suggest that, but what I do see people doing more often than not is reordering those. I've kind of grown up in the software, so I'm used to seeing them in a specific order. That is the Moldflow default order. But if you want to change those to be alphabetically, you can click the order button and change the order as to your liking. Again, we talked a little bit about the environment toolbars up top. I mentioned the Home tab. Again, it's a good for newcomers to the software. It's kind of helping you guide you through a particular workflow. But in the event that you want to do something like advanced runner creation or cooling channel creation, you may be prone to using the geometry tab. A lot of commands here that we can utilize, such as creating curves, beams, cooling channels, inserts, things of that nature. The next section, we'll be spending some time talking about the mesh tab and all those fun icons that are included in that particular workflow. And then we also have some external ones such as boundary conditions, right? If we want to assign venting locations, or if we want to assign cooling inlets, outlets, if we're doing something like gas assist and we want to apply a gas entrance, those are all nodal boundary conditions that we can apply through this particular tab. And then ultimately, I think one that is important to point out is the results panel. Obviously, after a job has completed successfully, we want to look at the results. That's the whole point of doing this, right? So we may be spending some time in here using the animation features, the examine features, the visualize warpage features, or creating new plots that may help us answer some of those questions that we had listed on the screen prior to that. As I mentioned, there is also the log files as well. We can turn those on and off depending on where we are at in the workflow. Again, a lot of good information can be contained within the log files. We'll talk more about that when we get into the results interpretation section. So that's pretty much the user interface in a nutshell. I'm going to walk you through how we can import a model. So I'm just going to use the home icon as well. Please note that you can also use the quick access toolbar to do the same importation feature. So I'm just going to hit import. I'm going to go to the file at which my CAD body is saved. In this particular case, I'm going to be adding or importing a step file of this particular GPS cover. As I mentioned, there's a couple different mesh types that we can utilize. Not really that critical at this point in the game, but I'm just going to go ahead and hit 3D here and hit OK. This particular GPS cover that I have already solved, I did run this as a true 3D tetrahedral mesh, so we'll get into some of the results that you can see for that particular case. But in the event here, you can see that I've simply just imported my GPS cover at the part only level, and it is in the proper orientation, so I don't have to worry about moving any of the geometries around. Really, the next step in our Moldflow journey is going to be applying a mesh to our CAD model, which is exactly what I want to talk about now. So we've got some basics on the user interface. We've successfully imported a model. I'm going to take a step back and look at mesh, the different mesh types, and some of the cleanup tools available in Moldflow meshing. When I first started using Moldflow Insight back in college in 2002, I remember on one Thursday night, my professor, who happened to work for Moldflow at the time, assigned us a homework assignment where he told us to clean up a very large model, and he told us that it took him 4 hours to clean up the mesh, so he would expect us to take 6 hours to clean up the mesh, which is exactly what I wanted to do that particular Thursday night. I can tell you that that same model that took me 6 hours to clean up would probably take less than 6 minutes to clean up, if any cleanup was needed on that. So lots of improvements on our meshing technologies, and really mesh cleanup is something that we did put a lot of emphasis on in previous years, but it's becoming almost automatic at this particular point in the game. One thing that is important to talk about, again, for new users, we are de-emphasizing the importance of mesh cleanup. So one of the new features that we released for 2018 is a one-click analysis. So before, we would have to import a CAD body, set the orientation, mesh it, clean up the mesh, and then solve our job. What we can do now is a one-click analysis where we can apply an injection cone to the CAD body itself. That's basically the yellow cone that you see on my GPS cover. So I've applied this to a CAD body. I can set up my analysis, fill pack, warp, pick a material, set my process settings, and just hit start analysis. And this is going to mesh the part behind the scenes and run the analysis in 2 steps behind the scenes. So it can be a little bit faster if you're trying to get something up and running, late on a Friday afternoon. And this is a little bit more advisor-like. So users that are coming from advisor to insight, this is a little bit more homier feel because it's very similar to how the advisor workflow would go. I think if you have people like myself and Tim, we've been meshing parts for years and years now, so we're a little bit reluctant to give control of the mesh and mesh cleanup directly to the software, so we still like to do it old school, but I can see sometime in the near future that mesh cleanup is really not going to be needed. So I've said the word mesh a lot so far. I want to take a step back and just let you know that a mesh is basically taking a CAD body and breaking it up into smaller subsegments. The reason why we do this is essentially all the magic or calculations occur at the vertice of these mesh elements. And when we talk about Moldflow, we've got several different mesh types that we can utilize. Things like a beam element is a simple cylinder with two nodes at the edge or top edges of the cylinder. Beam elements are often used for things like cooling channels and simple runner geometries. Triangular shape elements are kind of pictured in the middle. This is what we use for our midplane and dual domain mesh types. A dual domain mesh is kind of like a shell mesh, whereas a tetrahedral pyramid looking element is what we use for our true 3D mesh types. So again, different mesh types available to us in Moldflow Insight. As I mentioned, nodes are extremely important. Nodes are at each vertice of our various element types. And again, what's important about a node is we're going to be using these in the event that we have to do some mesh cleanup. We may be moving the location of these nodes, merging nodes together, but also when we get to adding injection locations and cooling inlets, this is a nodal boundary condition that we would assign to that given node or beam element if it is a cooling channel. As far as the various mesh types available, as I mentioned, the beams in the upper right-hand corner, we use these beams for hot runners, cold runners, cooling channels as well. But in terms of a part mesh, as I mentioned, we kind of have three different routes that we can take. If you look in the upper left-hand corner, you can see my CAD model that came in. And underneath that, the first mesh type that we have referenced is a mid-plane mesh. This is a little bit older technology. This is utilized more for very large parts that could be difficult to analyze in a 3D capacity. So what we're essentially doing is taking that 3D model and collapsing the main body and the ribs down to a planar mid-plane flat triangular element. The second mesh type that we have available at our fingertips would be a dual domain surface mesh. So it's kind of like putting a surface mesh on that particular CAD body. We typically use dual domain for thin-walled and larger parts because it's a little bit easier to analyze larger parts maybe with a dual domain mesh. Now we do take some assumptions there on our dual domain mesh, which is why we also offer a 3D mesh. 3D mesh, we typically like to see this for chunkier parts that have a lot of wall thickness variations or very thick parts because the tetrahedral mesh actually has tetrahedral elements through the thickness of that particular mesh. So we just get a little bit better resolution, particularly on thick, chunky type geometries. Now I mentioned you can do runners as beam elements. You can also do runners as 3D tetrahedral elements in the event that you also have a 3D mesh on your part. Now I often get asked the question, should I use 3D elements on my runner system or should I use beams? So the answer I have there is if you're doing runner sizing, it could be easier to do those as beam elements because it's a lot easier to change the beam properties, change the sizes. But I personally would like to see maybe the runners backed up with the final analysis that the runner is a 3D geometry. I am getting a question here about a very large part. Would it be difficult to use a tetrahedral mesh as the model would be very large? So I know Tim and I kind of try to push the limits of the software. So very large parts, if they are relatively uniform in wall, I do feel like a dual domain mesh would be applicable in that capacity. Several years ago, we launched our cloud solving capabilities. So I know Tim and I often solve jobs on the cloud. So if we do have a very large part, it could be beneficial to mesh it as 3D and solve it on the cloud. That would kind of free up our local machine or our server from doing the heavy lifting on the calculation. So it is a good question, and I apologize I don't have a silver bullet answer there, but Tim and I basically would suggest that you really have to evaluate your part geometry to determine if it is a dual domain or a 3D mesh type. Again, thin wall parts could be ideal for dual domain. Chunkier parts could be beneficial for 3D. With the generate mesh, a couple different options here. One of the things that is important to point out is that under the mesh tab, we have a generate mesh. This is how we would apply a mesh to a particular CAD body. If you've used the software in the past, you may be familiar with the global edge length, which I've kind of highlighted here. The global edge length is kind of how we used to mesh in the past. We used to assign a value to that global edge length, and it would basically change the size of our element, larger or smaller. One thing that we did incorporate, I believe in version 2017, we now have this auto sizing feature. So this is really, it's on this second tab where it says CAD here. And this would be what the default mesh is kind of driving behind the scenes. This auto sizing is just a scale factor. The default is 1. If we were to change the scale factor to be 0.5, we would put a tighter mesh on there. If we would increase that scale factor from the default of 1 up to 2 or 3, it's going to put a more coarse mesh on there, which may have a faster solve time, but we may lose some resolution on some small features. So be mindful of this, that you can change this global edge length like we did in the past, but it's not going to do what we think it's doing because the default now is under the CAD tab and that auto sizing. If you want to go back to the way we did it circa 2016 or previous, you would have to check these use global parameters, and that's going to drive it back more so to what you're used to seeing in previous releases where we have the global edge length as well as some of our chord angle controls, which are grayed out in this particular case. I think Tim and I are on the same page. We, as I mentioned, kind of grew up in the software, so you can go right to a 3D mesh. I believe Tim and I still like to generate a dual domain surface mesh, check the quality of that surface mesh, do any manual adjustments to the mesh, and then convert that clean dual domain mesh to a 3D. I don't think you would get the wrong answer if you jumped right to a 3D. It's just Tim and I are old and we don't like to change that much. So you can do either one. I know Tim and I still kind of evaluate the direct 3D route, and it is getting a lot better. I would assume in previous versions we probably would not have to do any manual cleanup, as I mentioned before. As soon as you mesh apart, giving your various controls, scale factors, chord angle control, global edge length, it's very important that you check the mesh statistics. Now, in the on-site training that Tim and I offer, meshing, we do spend about an hour or two talking about meshing and the various aspects of it. But the mesh statistics is a very good best practice to get into. Anytime you mesh apart, I highly recommend that you check the mesh statistics. In particular, I look for things like connectivity regions. In this particular case, I have 2 regions. If this was an overmolding assembly, that's okay to have 2 regions. But if I brought in a part only and I have 2 regions, that could be a case where half the model is not connected to the other half. Pretty rare occurrence, but I have seen it in the past. Aspect ratio is something else that Tim and I probably look for. We've changed our aspect ratio guidelines for both dual domain and 3D. In previous years, we'd like to see a 6:1 aspect ratio. Now we would like to see an aspect ratio of less than 20:1 on our dual domain surface meshes. There are some other aspects here that are important to point out. You can see that this element intersections, I have 429 intersections that could be problem areas. I probably would have to fix those, and you'll notice at the bottom of my mesh statistics, it says I have mesh defects that need to be fixed. However, this part is suitable for dual domain analysis. So again, the question that was asked, should I use dual domain or 3D? If you mesh it as dual domain and run your mesh statistics, it will help give you some guidelines as to, is the mesh ideal for dual domain? In the event that we have a poor match ratio, that may be a case where we go to 3D because match ratio or match percentage would be less critical given that we have the tets through the thickness. We do have some mesh repair tools available on the mesh tab. I'm going to briefly show these in the software. There are some frequently used tools such as merge nodes and swap edges. We do have some infrequently used tools that are kind of buried in the drop-down, such as smooth nodes or project mesh. Don't use those as often as merge nodes and swap edges. This is kind of a little bit like an art form. The more you do it, the better you will get at it. There is a mesh repair wizard option there. If you are feeling frisky, you can go ahead and do that. At least I personally do not like to do this because I like to change the mesh manually so I know exactly what's being changed. Sometimes if you do the mesh repair wizard, it will modify things behind the scenes on the mesh and you may not be aware of exactly where it's being adjusted or cleaned up. As I mentioned, very similar to dual domain surface mesh, we can also go right to 3D. The 3D mesher would have the same CAD tab with the auto sizing. If we go right to 3D, we do have a tetra tab that would allow us to assign the number of tet layers through the thickness. The default for plastic or thermoset parts would be 10, whereas other components such as mold inserts or part inserts would be meshed slightly differently with a tet layer of 6 through the thickness. We can adjust these as we see fit. I wouldn't recommend going much below 6 or 8. I do have some customers that increase the number of tets through the thickness to 20. Really part dependent, and obviously the more elements you create through the tet layers or your surface mesh, the longer the solve times would ultimately be. So with that, we'll go ahead and jump back into the software and I'll show you that one, how to create a mesh, and then how to some of the mesh repair tools at your fingertips. So if you remember the cover that I imported on the previous exercise, I'm going to go ahead and switch this back to a dual domain mesh. You'll notice that I can do that from the Home tab. Again, I haven't meshed anything yet. It's just going to change the controls that I have available to me. You'll notice that the 3D mesh type that I have solved here has a red icon designating that it is a 3D mesh, and it does tell me how many elements that I've currently have there. This blue icon represents a dual domain mesh. Again, I haven't meshed anything, but when I go to my mesh, generate mesh, you can see that it's basically going to be putting a surface triangle mesh on this particular component. Again, the general tab has our default global edge length. Please note that changing anything here will not physically change the mesh. If you want to put a tighter mesh on there or a coarser mesh, I would recommend that you use this scale factor. Typically, I found that the default scale factor of 1 is quite good at capturing most geometries. There are times that I have gone down to 0.75, maybe 0.6 on my scale factor to get more resolution on small features. I rarely go higher than that to create a coarse mesh because, as I mentioned, Tim and I do most of our solving on the cloud, so we're a little bit spoiled in that we don't have to worry about local solve on our machine or a central server. We do have a preview icon that we can preview the mesh before we physically hit go. So you'll notice that I have all these purple dots on here. This is kind of giving me a frame of reference for where it's going to put nodes. So I can zoom into small features like these keypad holes to kind of see where the approximate node locations would be. Is it producing the accuracy I need on small features like that? Typically, what I would recommend to anyone that is kind of trying to put a coarser mesh on certain areas, I can go in here and select a CAD body and then go up to this density tab and put a local mesh density on some small features that are important to me. What this is going to do is put a local mesh density on that surface of that feature without refining the mesh on the entire model. So what I'm getting at is you can use the default auto size of 1 on the majority of the part and then put a local mesh density on areas that are important to you at the end of filling, or maybe an assembly feature like a snap fit. Again, this is kind of the default view if we were to mesh this as a surface mesh. If I were to switch this to a 3D mesh and go back to generate mesh, you'll notice that it looks very similar for the general and CAD tab. However, now I actually have a tetra tab that I can assign the number of tets through the thickness. I'm just going to go back up to something that I've already meshed. This particular GPS cover that I've previously meshed is a dual domain surface mesh. So as I mentioned, after I hit mesh, one of the things that I highly recommend is that you check mesh statistics and then click show. And this is just going to do a diagnostic on the mesh that I have created. A couple different ways that you can do this. Back in the day, we used to have this populate just like this. So if I click this arrow, the mesh statistics pop up in the middle of my screen, or you can view it on the side panel there. So again, I don't want to go into a complete thesis on meshing, but I do want to point out some things that are of concern. As I mentioned, I have one part, one region, that's a smiley face. My aspect ratio is a little bit higher than the 20:1 recommended that I spoke about in PowerPoint. My edges look good. I don't have any overlaps or intersections. Again, this is kind of the norm for most CAD coming into Moldflow Insight these days. My match percentage is a little low for dual domain. I do have some chunkier sections to this GPS cover. So the mesh statistics tells me that, hey, this might not be an option for dual domain. That's telling me that maybe I should think about a 3D mesh type as I ran on this particular part. So depending on what the mesh statistics tells me, that kind of dictates what I need to clean up. In this particular case, the only red flag is that the aspect ratio is higher than the 20:1. So I'm going to take a stab at addressing that. There are several different diagnostic tools that we can look at. So as I mentioned, aspect ratio was the only kind of red flag that I looked at. And so I'm going to go ahead and click aspect ratio and leave it at the 20:1 minimum and click show. And what this is going to do is it's going to show me all of the aspect ratios that are higher than 20:1. And without going into too granular detail, an aspect ratio that is higher, say, in this particular case, about 29:1, it's kind of like a long skinny element. The reason why we want to clean this up is long skinny elements or elements with high aspect ratio can be a little bit difficult when we get into things like cooling and warpage. Not so much on fill, but that's definitely something we want to address. I am getting a question in here about lower limits for dual domain. There really is no lower limit. I will tell you that usually the average aspect ratio is quite low, in the range of 2:1, 3:1. So that's definitely a low number. We're mainly concerned about the high values. I'm also getting a question about the match percentage. Again, match percentage is more critical for dual domain because it is a shell mesh. So we want to see a match percentage of at least 85 for a fill analysis. If we're continuing on to warpage or cooling analysis, I would want to see that slightly higher in about 90%. So depending on what we're wanting to do with the software, it kind of guides our recommendations. Again, we spend a lot of time in the training talking about this, and we do have some cheat sheets for the different mesh type as far as recommendations on aspect ratio, match percentage, edge details, things of that nature. But because I, again, am focusing on aspect ratio here, I do have an aspect ratio that's slightly higher than the 20:1. You'll notice that this red tensor shows up and it's pointing me to my problem area. Also, I can click on the mesh panel and go to this entity navigator and click this arrow button, and it takes me right to my particular problem area. I can use the center tool to rotate the model about this particular problem area, and you'll notice that it's pointing me to this long skinny element in this particular case. This is kind of where the you have some choices. We can do some things such as move nodes, merge nodes, swap edges, and the more that you do this, the better you will get at it. In this particular case, I'm just going to use the merge node function, and I'm going to merge one node to the next, and you'll notice that yes, I did deform my CAD a little bit, but for the sake of this particular analysis, I don't think I will be losing much in accuracy. As soon as I merge those nodes together, my diagnostic tool goes away, and that means that essentially I don't have any more aspect ratios that are driving that particular component to be relatively high. Anytime I change something such as overlaps, intersections, aspect ratios, it is a good best practice to recheck your mesh statistics, just making sure that we don't do any more harm than good in terms of cleaning up that particular mesh. So I'm just rechecking my mesh statistics, and I'm just making sure that cleaning up that aspect ratio did not deform the mesh in a manner that was unexpected. So one nice feature that is going on right here, we do have an autosave feature, so this is saving my model behind the scenes. But if I were to click on this mesh statistics again, you'll notice that my aspect ratio went from being above the maximum 20:1, it was 28. Now it is down to 19.72. My edge geometries and everything else looks ideal. What I can then do is save a copy of this. So the way I like to do this is save a copy of my dual domain mesh, and then create a copy rather of that dual domain mesh and convert it to 3D and then mesh it there. The reason why I do this workflow is kind of twofold. As I mentioned, I'm still unable to give control of the meshing directly to the software, but there are some analyses such as molding window that I use heavily that is a dual domain specific analysis. So what I'm saying here is I use a dual domain version of that to run a molding window to get my process settings that I would then feed back into my 3D fill pack warp or cool fill pack warp analyses. There are some other mesh edit tools, but again, like I said, the meshing has become pretty seamless. I would say that more often than not, I rarely have to clean up a mesh, but I do like to check the mesh to ensure that I have a quality mesh that is going to help me produce the most accurate results. I'm going to jump back into PowerPoint. I'm going to talk a little bit about how to set up a basic process setup. One of the things that you will notice that when you import a model, it is going to default to a fill analysis. Sometimes a fill analysis may answer your questions, but maybe you would need to change that. So you can either double click the fill icon in the study tasks or go to the home molding process setup analysis sequence and change that from the default fill to whatever analysis sequence that you may be running. Keep in mind that there are different analysis sequences such as gate location and molding window that are more part-only type analyses, and I will cover those when we get back into the software. After that, you can see that the study tasks, much like the home tab, is working its way top to bottom. I've set my analysis sequence. Now I'm going to select my material. We have over 10,000 materials in the Moldflow database. So you can easily search by manufacturer, trade name, filler content, viscosity index, filler concentration. So you can either do that by selecting the manufacturer trade name, or you can do a more advanced search command to try and find the exact material grade that you are looking for. Much like our default fill analysis, the default material that you have selected is going to default to a generic polypropylene. So I would encourage you to obviously pick the correct material at this point. Next thing we need in order to solve most analyses would be an injection location. An injection location looks like those yellow cones that's in the middle of my GPS cover there. Again, this is a nodal boundary condition, so we can apply this either to a CAD body or to a mesh, and it's going to assign basically like the injection nozzle is right there. I understand that that's probably not the case, but one of the methodologies that we teach in the Moldflow fundamentals is we want to address some filling conditions on the part only before we start building our runner system. So this is a good way to address any fill concerns that may show up simply by putting an injection location right on the part. If everything looks good there, we can then run another analysis with our runner added to. Process settings, again, the process settings are going to vary depending on, I guess the process settings inputs that we have available to us are going to vary depending on whether we have the analysis sequence set to a fill analysis. In the event that we run a cool fill pack warp as opposed to a fill analysis, the inputs are going to change depending on our analysis sequence. If we are starting from scratch and this is a new part, new material, we don't know how the processor would process, you can kind of loop in your process engineers and get a starting point of what they would recommend. Or we do have some tools that I will cover in software, mainly the molding window analysis. This can be a very detailed way of trying to identify what our mold, melt, injection time, cool time should be based on that part geometry, that material, and that injection location. As I mentioned, this is a particular process setup for a cool fill pack warp analysis. Please note that if we decided to do a fill pack warp or a fill pack analysis, some of these processing wizard inputs may change slightly. You can see that we can import our melt time. The melt temperature is brought over automatically from the material manufacturer recommendation. If that is the melt temperature that you want to analyze, go ahead and use it, or you can adjust that value based off of historical knowledge or what your process engineers may deem required. I can specify a mold open time as well as an injection packing cooling time. Again, this is specific for a cool fill pack warp analysis. On the second page of the wizard, I can specify my filling control. This particular analysis, I've set it to be by injection time. We can do this by injection time, by ram speed, a lot of different variables that we have for filling control. Same thing with velocity pressure switchover, our VP switchover, or our transition from first stage velocity filling to second stage pressure or packing. We can set that to be by a percent volume filled, by a value at a certain node location. If you do any type of scientific molding, decoupled molding, again, your processing engineers should know what they typically look for when they set up a process. Pack and hold control, again, some options that we have there. You can do it by a percent filling pressure versus time, or you can do it in absolute pressure versus time, and I'll show you what that looks like in the software. Lastly, because I did set this up to be a cool fill pack warp, I do have a warp page. You'll notice that I've isolated the cause of warpage. We'll talk about this more when we get into the results interpretation, but isolating the cause of warpage can be a deeper level of looking at our warpage, not just seeing how the part's going to warp, but ultimately identifying the root cause of the warpage. So I highly recommend that if you are looking to fix a warpage problem, that you may want to check that isolate cause of warpage so we can identify, is the warpage stemming from a cooling problem, a differential shrinkage problem, or an orientation. So with that, I'm going to jump back into the software, and I'm just going to bring up a couple analyses so you can see the difference. Actually, before we get to that, I do want to talk about some part-only analyses. As I mentioned, depending on what the analysis sequence that we select, right, maybe we want to determine the ideal gate location. We do have a gate location analysis that we can run. And if we check on some of these results, it's pretty simplistic. It gives us a flow resistance indicator or a gating suitability. Again, so I've actually run a gate location analysis on this. It's just something available to you that is going to help guide you as to the best gate location for this particular part. This is somewhat basic. It is going to try to minimize pressure to fill. So I do understand that you may have restrictions on where a gate can be. We can go up to our boundary conditions and prohibit gate nodes. What this is going to do is prohibit a region and not put a gate there. It'll just give us a deeper level gate placement analysis. Another tool that can be available to us, if we go back to my trusty CAD part that I just imported. Again, I haven't meshed this part. I haven't done anything besides import this. If I go to set injection locations, I can put an injection cone on my CAD surface. And when I do that, my fill preview box populates. This fill preview, again, I haven't run any analyses, but I can kind of incrementally step through time to see what this resultant filling pattern is going to look like. Is it going to be balanced left to right, or am I going to get some underflow or diverging flow in this this screen area? What's nice about this is I can update this real time with multiple gate locations, and it will give me an updated filling pattern based on 1 or 2 gates. Finally, before we get into the advanced process setup, I do want to show you molding window. As I mentioned, molding window is one of my favorite analyses. This is a part-only analysis. So what I've done is, again, I've just meshed the part as a dual domain surface mesh, and I've added an injection cone and selected a particular LG chemical material. The molding window analysis will give me a snapshot of what my melt, mold, and injection time should be. So I have melt on my x-axis, injection time on my y. Mold temperature is actually going in and out of my screen, but I can actually page through that different mold temperature to see this green swath of preferred processability. Again, this would just allow me to pick what my mold, melt, and injection time should be. In this particular case, I'm just going to use some values here, but I would like to be, somewhere obviously in this preferred region. That's going to allow our processors to have the easiest day for processing this particular part geometry with that material. We can actually take that to a deeper level. I can look at things like my pressure drop. If I were so inclined, I can change that to be injection time on the x-axis, and I can see what my resultant pressure drop would be if I vary things like my mold or melt or my injection time. For example, if I move my melt temperature, you'll notice that my pressure to fill this cavity is going to be adjusted. Really, this is just a sanity check to make sure that we have the capacity to fill this particular part. Again, it can also get us a pretty good starting point of what our input should be for our process setup. Very similar to the pressure to fill, I can also get an approximate cooling time required for this particular part. So if I select my melt and mold temperature and then use this examine tool to figure out where I want to have a fill time, it's going to generate a value of my y-axis of around 16, 17 seconds. So again, for trying to quote a particular job, we very quickly have some answers as to injection time, cooling time, melt temperature, mold temperature that can aid us in the quoting process. The value of the molding window is that it runs in a very short order. This particular molding window analysis took 3.52 seconds to run. So in a matter of 3.5 seconds, we've identified our mold, melt, injection time, and a ballpark cooling time that we can then feed into our fill analysis or fill pack warp analyses. As I mentioned, depending on whether or not we use the default fill analysis, so if I just use default fill, you'll notice that my process settings look a little bit different than what we explained in the PowerPoint. I can set this up to be a mold and melt temperature based on the material manufacturer, or I can adjust this based on my historical knowledge with that particular material. Under filling control, I typically do injection time or flow rate. If I have ram speed or press information, I can specify a ram speed profile that may be slightly more accurate than just a generic fill time, but usually injection time does pretty well for me, so I'm just going to go ahead and enter a value of 0.5 seconds for my filling control. VP switchover, again, lots of different options that we can pick through here. The way I was taught to process, I typically was taught to do a volume filled of 98% full. So that's how I'm going to set that up. I understand that there's different companies out there that teach different methodologies: scientific molding, two-stage molding, decoupled molding, whatever you want to call it. If you want to set this to be 95% full, 90% full, go for it. You have the ability to do that. Pack and hold pressure. I think there was a question of what else is available for pack and hold. You can set this up to be a percent filling pressure versus time, pack pressure versus time, which is an absolute pressure versus time, hydraulic pressure versus time, or machine maximum versus time. So usually this is going to be a time dependent capacity, which is very similar to how our injection molding machines are set up. I'm getting a question, what do the automatics do? I typically do not like to do the automatics, especially with VP switchover, because the automatic VP switchover is going to take this to 99% full, which could be different than how you're processing. For example, if your processors are transferring at 95% full, inherently your VP switchover is going to be slightly inaccurate. So I'm a fan of setting this up to be a volume filled if I do know that. Filling control, it's going to try to, if we have this set to automatic, it's going to try to make some assumptions as to the best guess at our injection time. This may be a little bit slower than what our processors do, but it is not a wrong workflow. I typically like to run a molding window because I have that zone plot telling me, okay, Mason, why did you pick 0.5 seconds? I can show them, well, my zone plot looked clear in this particular area. I'm confident I can fill this in 0.5 seconds. Again, if we were to set up a cool fill pack warp analyses, our process setting variables may be slightly different than that of just a fill analysis. So again, process analysis type is going to dictate what options we have available to us. Again, a cool fill pack warp is going to look very similar to what I talked about in the PowerPoint segment there. Predominantly, if we go to the pack control, the default pack setting is 10 seconds at 80% of our fill pressure. Again, this is just the default setting. We can adjust this accordingly. For a new part, I typically leave it at the default unless the customer explicitly tells me that no, we typically pack for about 50% of fill pressure. By all means, you can change this to be from the default of 50 to 80. And then if you do run relatively small parts that the gate freeze time is usually around 4 or 5 seconds, you can change that. That's no problem at all. But I typically like to go high in order to see exactly when the gate freezes and then adjust my pack time accordingly. I am getting a question here in regards to pack and hold. It is always going to be versus a time input. So no matter what we do, it is going to be during time. You may be wondering, why do I have this 0-50 timestamp and then a time of 10 seconds and 50%? What this is doing is kind of creating a knee in the curve. So if we have the ability, if we just set this up to be 10 at 50 and didn't have that second timestamp, if we hit plot profile, it's not going to show us much, but what this is going to do is ramp down from our filling pressure to our 50% value. We need to have that knee in the curve to kind of drop the pack pressure to 50%, which is more representative of how we would typically process at a injection molding machine. And then warpage, we do have some ability to isolate the cause of warpage, as I stated before. That's just kind of the basic fill or fill pack warp analyses. Obviously, when we start getting into more exotic type analyses, such as mu cell, gas assist, if we want to run a core shift analyses, those process variables would change slightly. So getting into the fun stuff, results interpretation. Results interpretation is probably one of the most critical aspects of looking at a Moldflow report. So we as analysts, it's kind of our job to look at things and make sure that we are addressing any potential problems before they become expensive problems. With Moldflow Insight, again, a little bit different than Moldflow Advisor. We have a lot more capability in terms of more detailed analyses. We have single data sets. This would be essentially one value, either during filling or packing. Intermediate results would be recorded through time. Intermediate profile results would be recorded through time and thickness. XY plots, those are kind of self-explanatory. Those are a 2D graph representing clamp tonnage, pressure, things of that nature. A highlight result would be something like a weld line or an air trap. It's just visibly showing you where that particular issue or potential issue is through a highlight feature on the model. And then text files would be information that we gain through our log files. As you can see here, I have a wide list of results that we can evaluate. So the way this is set up, I have flow results. For this particular one is the plots that you would generate for a dual domain type analyses. I have cool results that we would get from, it looks like a beam element on our cooling channel. And then I have a warp folder that has all of my warp plots. It looks like I've checked the isolate cause effects because I have the ability to look at differential cooling, differential shrinkage, and orientation effects. On the right-hand side, I have some flow results that are specific to 3D type mesh. So you can see, particularly on my 3D, or excuse me, on my weld surface movement and weld surface formation, they do have a 3D in parentheses. That's telling me that I do have a 3D mesh type. So you will get slightly different results between dual domain and 3D. They should tell you very similar information. It's just their names slightly different based on those two different mesh types. I've just pulled out some of the Mason Myers special, some of my favorite results that I typically look at. Please note that this is not always the case. For example, I have customers that I work with, and all they want to see is the warpage all effect or the deflection all effects. So sometimes I have customers that just want to see deflection all effects. Other times I have customers that want to see fill time, pressures, temperatures, clamp forces, volumetric shrinkage, the whole gamut. So again, going back to why are we running this analysis in the first place? That's really going to dictate, one, our analysis setup, our analysis type, as well as which results we ultimately decide to review to answer that question of where are my weld lines going to be? Where are my air traps going to be? Is my warp within tolerance? Is my cooling channels optimized? Again, so it's gonna help us drive us to the ideal workflow as well as which plots we need to evaluate. I don't have a lot of static images in the PowerPoint, so I find that it's easier to review the results in software. So in terms of the PowerPoint, I do have some screenshots of the plot properties. If we right-click on any plot, such as fill time, temperature, we can get a list of plot properties. These are really just visual aspects that we can change, to our liking. So again, Tim may like the banded approach on some of his analyses where I'm more prone to looking at the smooth color transition. Again, just a personal preference. Tim could be right in that the banded approach or the contour approach could help show us things like hesitation. So again, these are all personal preferences. When we get into some of the animations, we have the ability to increase the number of timestamps. And then some of the contours, I will show you when it's applicable to modify those in software. What's nice for new users and sometimes experienced users in the event that we're not really sure what we're looking at. So in this particular case, I'm looking at the frozen layer fraction on a dual domain type part. What the heck does that tell me? If we simply hit the F1 key, it will take you right to our help files that are either installed with the software or a website that will tell you exactly what the frozen layer fraction is and what it means to us, how to use that plot. So again, if we're looking at plots that we're not familiar with, go ahead and hit that F1 key and it will help you guide you as to exactly what the result is that you're looking at. So I'm just going to jump back into the software and we're going to take a look at some of the results that we can generate. In this particular case, I've ran a cool fill pack warp analysis, as you can see from my icons in my study tasks. Again, there's no real wrong answer here. If you're looking for warpage numbers, you can jump right to the deflectional effects, but I'm going to kind of go through a methodology that we kind of teach in the fundamentals. And first and foremost, again, fill time is usually one of the first plots that we evaluate. Nothing wrong with that. A lot of information can be gained by looking at the fill time plot. Anytime we're looking at any plots in particular, you need to pay close attention to the scale bar that's on the left-hand side of the display window. This is going to help you to identify a little bit deeper of what this is showing me. So fill time plot is actually a time stamp. So in this case, red is not hot, blue is not cold because it is a time designation. Some plots are geared towards animation. So obviously a fill time plot, we can incrementally step this through time. We can see what the filling plot looks like at different timestamps. So again, the color indicates the time at which that area fills. Ideally, what we want to be looking for here is a balance of fill. We want to have the extremities fill at about the same time. Of course, on my particular GPS cover, I am breaking that rule in that my end of fill is actually up here on the screen, whereas the lower keypad area has filled before that. Again, this is This is not a perfect world, so again, this is why we're running simulation to evaluate different gate locations, different part geometries, different materials. But that's definitely a way that you can evaluate fill time. Again, I incrementally just hit the step forward button. Please note that you can just push play and kick back and watch that fill time animate through time. You can loop that if you were so inclined, and it's just going to keep animating the fill time over and over again. And then if for whatever reason we have a bounce feature, which you can actually see the part cavity unfilling. I do have some customers that like this particular bounce feature. Again, that's a personal preference. I don't really see much information gained from that. I'm just going to step through and walk you through a couple of these plots. You'll notice that the pressure at VP switchover. So this is the pressure at which we transfer from first stage filling to second stage packing. Usually it's the highest pressure value in the system. And again, I would expect that to be mainly at our injection point or at the machine nozzle. Pressure is usually 0 at the flow front. If we look at pressure at VP switchover, obviously this is showing you the pressure in the different areas of the part. If you have or come from a processing background, the pressure at injection location, it's just an XY plot showing pressure versus time. Again, it's telling me the same information. It's just a matter of how you want, what's easier for you to interpret the results. They both are seeing the high pressure value right at my transfer from first stage filling to second stage packing. And you can ultimately see my pack profile. So what this is telling me is I have pressure generated in the system during filling, and then based on my process control, it drops down to 80% of that value, and I'm going to pack and hold that for 10 seconds. Pressure is going to be dropped off, and I'm still in my cooling phase at this particular time. Clamp force value, again, is often used in an XY plot. This is often used to help us select the machine capacity or the max clamp force in this particular system, so we can select a proper injection molding machine to ensure that we're not either pressure limited or clamp limited on our capacity in this particular case. There are certain plots that I always look at, right? Fill time, warpage, temperature, pressure. Obviously, I think those are important. But there are times that, certain plots that I may not look at. For example, grow from. Grow from plot, let's see if this is set up right on my system. So if I hit F1, it takes me right to the help file, and it tells me that the grow from plot is used when we have more than one gate, and it shows you the distribution of fill between one gate to the next. If we go back to my particular Moldflow, you'll notice that I do have 2 cavities, so it's just showing me that all the blue material is filling from that particular gate, and all the red material is filling from that particular gate. In this particular case, probably not ideal to look at grow from, but if we are looking at a very large automotive fascia, we've got multiple valve gates firing at different times, definitely a grow from plot would allow us to see the distribution of material from each one of those valve gates. I'm just going to pick and choose some of my favorite plots. Shear rate, you'll notice that because I ran a 3D analysis, it looks like I've got a pretty low shear rate throughout the whole system. I'm good, right, Mason? But if we go back, 2 things that we can do. If I pick my material, right click and hit details, I can go through my recommended processing. In about average for this material family, we want to see a shear rate of about 40 thousandths reciprocal seconds. In this case, I'm a little bit above that. You can see I'm at about 52 thousandths. So I'm a little bit higher than the recommended range for this material. But again, because I'm using a 3D analysis, I can do one of 2 things. I can play this shear rate result through time. You can see that I'm getting some spike in shear rate by the color designation at the gate, but a better workflow here may be to go to under results. I can put a cut plane on this. I can cut this about the YZ axes, and then I can move that cut plane a little bit so I'm bisecting the gate region here. And now if I zoom into the gate region, I am seeing a little bit different picture that I'm actually spiking that shear rate in this particular area, mainly during filling, to about 40 thousandths, but I may also have some higher spikes in my sprue region as well. So just be mindful of that. It looks like I have some red here on the side of my sprue. I'm getting a question of, can you use a contour plot for shear rate? Absolutely. I'll get into that because I typically use contour plots more for temperature, but absolutely you can do that. So I'm just going to take off my cut plane. So again, I use cut planes quite a bit for 3D mesh types. That allows you to get in there and see inside the model on things that may be happening interior to our mesh because we are using a 3D mesh. Very much like shear rate, if we look at temperature, right, the temperature doesn't show us a whole lot because I am seeing a 3D mesh. I can animate temperature through time. Again, it's showing me that skin layer of the mold being about 128 Fahrenheit, and I do have a hotter region interior to my 3D mesh. Again, nothing wrong with looking at this plot, but I think there's a deeper way that we can look at that. Again, this is getting a little bit advanced for new users, but it's something that I use quite often. So I can actually go up to my flow results or up to my results panel, and I can create a new plot. So in this case, I'm just going to create a new plot and go to temperature animation, very similar to what I've already have, and that creates a new temperature 1 plot. Now, some of the things that I do in regards to temperature on 3D mesh types is I can set this temperature to the magical transition or ejection temperature of that particular material that my material manufacturer recommends. So for example, this particular material has an ejection temperature of 194 degrees Fahrenheit. And if I click on rheological properties, it has a transition temperature of 219 degrees Fahrenheit. What I can do then is go back to the temperature plot that I just created, right click, go to properties, go to contour, single contour, and set that to either be my transition or ejection temperature. In this case, I'm going to set it to be the magical transition temperature. And this is just going to show me all the material that is at or above that transition temperature at that particular timestamp. That's great, Mason. How the heck am I supposed to use this plot? What we can do with this plot is if we backtrack in time, you'll notice that more and more the model becomes molten per se. But how I use the contour transition temperature plot is to focus in on the gate region, and I can see essentially when my gate freezes off through the thickness. So again, this is kind of an easier way to help me identify gate freeze time. So I can see at this particular timestamp of 4.7 seconds, I still have molten material entering in my gate region. But if I play this slightly through time at about 6-7 seconds, I believe, this one might be a little bit, so definitely at 6.5 seconds, I get that break in material. That essentially means that my gate has solidified because it has reached my transition temperature, and that my default pack of 10 seconds is probably overkill because that other 3.5 seconds of pack is simply packing my runner system. If I was trying to minimize this cycle, I could use this information in my next analyses and set my pack time to be that of around 6 seconds. Very similar, we can do the same single contour and set that to be the ejection temperature. Again, I realize that on my particular part, I've got some thick, chunky areas that may not reach 100% of my recommended ejection temperature at the end of my cooling phase. How I would use this is I would kind of zoom in, again, This is no longer transition temperature, but it is ejection temperature. So what I'm curious about is areas that I may have ejection pins or ejector pins to ensure that the area around those features or that part model is actually reached the ejection temperature at this particular cooling time, so I can safely remove this from the mold, and I'm not going to deform or push my ejector pins through the part. Again, we have a lot of different plots to look at. A couple of these, for example, volumetric shrinkage, definitely important to evaluate this. Because I used a 3D mesh type on this, volumetric shrinkage is actually showing me this through the thickness. So again, we may want to go back and put a cut plane on this to actually see where the high volumetric shrink is. In this particular case, it's on the thicker sidewalls. Another way that you can visualize volumetric shrinkage is simply using the average volumetric shrinkage. In this particular plot would be easier to look at all-encompassing. So it is an average through the thickness, but it's telling me virtually the same thing, that on average I have a thicker volumetric shrinkage, or excuse me, a higher volumetric shrinkage in those thicker areas around my GPS screen. Obviously that could correlate to a warpage problem because I have that particular area is shrinking more so than other areas of the model, which could lead to a warp problem. Things like air traps, those are obviously pretty easy to see. Air traps in this particular case just kind of give you a visual idea of where you could have a potential for trapped air. We want to make sure that we have vents in that particular area. Very similar to air traps, if we look at something like weld lines, in this case I've already set my weld lines to be Tim's favorite color of hot pink, but we can set these to be various colors. And when we do that, we get actually a degree of formation. So again, this degree of formation of weld lines is not a temperature degree, it's the degree of angle of how these weld lines come together. Areas in blue are going to be weaker butt welds, whereas the areas in red are going to be more like a meld line. One other thing that we can do with weld lines, again, we can go into plot properties, and if we go to highlight, so looking at the weld lines as a degree of formation is definitely a good best practice, but we can also set those to be the temperature. So we can actually see the temperature of the weld lines in particular areas. In this particular case, let's see if I can do temperature flow front. Temperature flow front, there we go. This might be a little bit more descriptive. So again, if I show these to be the temperature of flow front, it's a deeper way to look at weld lines in that I'm actually seeing the temperature of the weld lines. Obviously in this case, weld lines that are at a higher temperature could be slightly stronger, as opposed to a slightly cooler weld line could be susceptible to a weak point. One thing that we can also do is anytime we're on a plot, we can go up to another plot, right click and hit overlay, and this would allow us to keep the weld lines visual, but now we can step through time and see the filling pattern create that particular weld line. So again, if we're trying to convey this to someone that's not that familiar to some of these visual defects, it's just a deeper way to look at how these flow fronts come together to form a particular weld line. Again, there's a lot of flow results that that you can evaluate. Tim and I spend at least 2, if not 4 hours talking about results in the more detailed hands-on training. But keep in mind that, it always goes back to why are we running this particular analyses. If I turn my cooling channels on, you'll notice that, again, a little bit outside the scope of today's course, I did use a runner system that I've attached to this particular part using the the runner system wizard, as well as I've put in some generic cooling channels to look at my particular cooling schematic. Both of these were utilized under the cooling circuit and runner creation wizard that's underneath the geometry tab. Again, just real quick, in terms of cooling results, there is a specific folder for cool results. Obviously, things such as circuit coolant temperature. Again, this is just showing me the rise of my temperature distribution. I'm obviously coming in these channels next to my inlets at about 122 degrees Fahrenheit, whereas the exit temperature is about 123 degrees Fahrenheit. So I don't want to have too much temperature rise in my cooling circuits. We do offer an advanced course that focuses solely on cooling and warpage, and we get a lot more detailed as to looking at different cooling results that can be generated there. I'm going to go ahead and turn off my cooling channels because lastly, what I want to talk about is warpage. So I'm just trying to give you a flavor for what's capable within the software. By all no means, I don't expect you to become an expert after a 2-hour webinar, but again, the more that you look at these results, the better you will be at analyzing your individual problems. So warpage obviously is a problem with most plastic parts, and it's definitely something that we can simulate through Moldflow Insight. I just want to show you a way that I look at weld lines and how, how we look at deflection or warpage and how that can streamline your workflow. Deflectional effects is a pretty good plot to look at. This is showing me the magnitude of warpage as well as the location. Now, something that's different between Moldflow Advisor and Moldflow Insight, Moldflow Insight allows us to look at shrink and warp, and I can actually remove the shrinkage from the tool if it's applicable. So depending if I'm coming in with my part CAD or my tool CAD, I can apply a shrink compensation factor here. Several different ways that we can do this. We can apply automatic, isotropic, and anisotropic. Automatic would give us our shrinkage values X, Y, and Z that would need to be applied to this model to get it back to nominal CAD essentially. So if your tool shop can cut in 3 directions, you can use the automatic or anisotropic and enter in those values explicitly. I do see a lot of tool shops still cutting in one direction, so we can apply an isotropic value that is your shrinkage. But what I'm getting at here is if we do the automatic, this kind of gets us a feel for what the shrink should be for this part, this material. Maybe a little bit different than the 1% listed on the tech data sheet for this material. In this particular case, somewhere between, 0.5 to 0.8 may be ideal for this particular model. Again, this really depends on if you're bringing in part CAD or tool CAD. But just real quick, getting back to warpage, at least how we typically view warpage, I can split the screen and I can look at multiple different types of warpage plots simultaneously. So in this case, I'm going to put the deflectional effects in the upper left-hand corner. I'm going to add the differential cooling up here. I'm going to put differential shrinkage down here, and then my orientation effects in this particular box. So one thing you may notice is that my orientation effects is 0. This is usually an indication that I have run an unfilled material. Had we run a material that has any type of fiber, obviously that would correlate to some impact on warpage. If I look at my differential cooling, it does have some color aspects as to how that part is warped solely based on my cavity core temperature, but the value is quite low. If I look at my differential shrinkage, the value matches that of the all effects, and the trend typically matches that as well. So this is telling me that my differential shrinkage, the differential shrinkage is the root cause of my warpage. Again, what Tim and I would talk about in the advanced class is this could be drill down to either a part design problem, a gate location problem, or a packing problem. So we need to change one of those three variables to try to um, reduce our warpage. There's really no need at looking at optimizing our cooling yet, because it's most of our warpage is stemming from a part design, packing, or gate location problem. Now, for those of you that did attend my advisor webinar yesterday, I realized that differential shrinkage was also the cause of that problem. Please note that this is not a cookie cutter. Differential shrinkage is not always the root cause. If you have a poor cooling system, obviously cooling can come into play. Or if you're fortunate enough, it could be a nice mix of fiber orientation, differential shrinkage, and cooling that's causing your particular headache. So again, it's important to look at warpage this way so we can identify and address the root cause of our particular warp problem. Had we not checked the isolate cause of warpage, we just would have gotten the deflectional effects X, Y, and Z component. There still is validity in looking at something like the Z component. For example, if we're worried about flatness on this particular surface in the Z direction, I would encourage you to look at warpage in that particular case. I typically break it down by the different subsets of warpage when I'm trying to identify the problem. But when I'm trying to get into measure warpage, looking at the X, Y, Z components explicitly would allow me to see what the height difference is in this particular case. Something else that we can do is also measure warpage. So if I go back to my deflection all effects, and let's just say that I'm worried about the a couple assembly features here, I can click on 2 points and it would give me the warpage or the deflection before and after deformation, as well as some of my shrinkage information between those 2 points. So again, I've looked at a lot of different plots here. Overall, I would say my results look pretty good, but I don't want to discredit the log files. Again, a lot of information can be generated from the log files, such as warnings or error messages. One of the things that, again, after looking at these plots, I don't know if anyone picked up on this, but I actually had a short shot on this particular problem. And if I look at the log files, once the analysis completes, just above my runtime or the time to solve, I do get a warning 220131 short shot detected. So again, we looked through all those results, and it may not be obvious that we had a short shot, but again, warning messages and error messages would populate in the log file. So that's a key piece of information. I need to go back and figure out what the heck went wrong here. And if I go back to my flow properties, or my flow results rather, you'll see that if you do encounter a short shot, a plot would populate called unfilled cavity. This is essentially showing me that this boss feature on the underside of the part did not fill properly and created a short shot. If I go back to my fill time animation, again, if we look at the underside of this particular part, I'm still filling the main body of my GPS covers. However, we can see that that boss feature here is stagnating in flow and not filling out properly, and actually generating a short shot that does not fill 100%. So again, a lot of good information in the log files in terms of error messages and warnings, and they will kind of help guide you as to what we need to do in the event you do get an error message and the analysis fails, or if there's a warning, you can obviously take a closer look at the corresponding result to see what happens there. I'm getting some questions that I do want to take a crack at answering. I apologize, there was one that was around optimizing flow based on the results, such as weld lines. You can do that. I know that is a common issue in automotive. So weld line positions, right, being in aesthetic areas. One of the things that you can do is it's a little bit easier to do on a dual domain surface mesh, but you can add flow leaders or locally change the thickness of a dual domain surface mesh that would allow you to simulate adding a flow leader so you can shift the location of weld lines or air traps to be in an area that is acceptable. So while there's no real way to say optimize filling based on weld lines, you can do some varying levels of analyses to look at the location of those weld lines and where they ultimately end up. Again, one of the other things that's a little bit outside the scope of today, we do have some design of experiments or DOE functionalities available. So I can actually tack on a design of experiment to any of these analyses, assuming we're on the appropriate flavor of Moldflow Insight. And what we could do is do a DOE based on injection time or VP transfer position, and that would allow you to see varying filling patterns based on those inputs to, again, shift the location of some potential problems such as air traps or weld lines. Jumping back to warpage, just something that as new users, I just want to make sure that we don't get tripped up on. You can run a cool fill pack warp analyses. Obviously, that's a very common analysis workflow that people do every day within Moldflow Insight. If you do a cool fill pack warp, I would highly recommend that you obviously have your cooling channels designed and modeled in the particular simulation. If you were to run a fill pack warp, what that is doing is assuming an isothermal condition. So it is, instead of taking the distribution from my cooling channels that I have modeled here, a fill pack warp would actually be giving you a perfect mold condition. So just be mindful of that, the difference between cool fill pack and fill pack warp. There is still validity in running a fill pack warp because that's essentially showing you what the warpage is going to be best case scenario. And that's ultimately what you should be targeting when you design your cooling channel. So just be mindful that if we run a fill pack warp instead of a cool fill pack warp, it is set to an isothermal condition of 1 mold temperature. That's rarely the case, and even if we're doing some very complex 3D conformal cooling, but there is still validity in at least evaluating that, because I understand that you may not have your cooling channels designed at that particular point in your workflow. So I know that we all have real jobs to get back to, so I'm going to wrap this up with the final section and leave you guys to go on your merry way. So how to get a hold of us. As I mentioned, if you need help on things, individual plots, you can use the help files or use the F1 key to help guide you through what you're looking at. I do feel like our forums are better than most, so there's a lot of information on forums. We have a pretty good user base that often help each other out, and I know our support personnel are active on these forums as well, trying to answer specific questions. If you do need to contact technical support, the easiest way to do that is to create an account through Autodesk. This just allows us to see who you are, what flavor of Moldflow you are currently using, and it's just a lot. It streamlines the process trying to get you in contact with our technical support personnel. Our tech support people, mainly around the Moldflow product line, are awesome. They are all degreed plastics engineers. So they've used the software in industry and they know what's going on. Obviously, reach out to them if you have any type of technical issues, or if you have licensing, installation, or registration problems, they can help you through that. We also have an Autodesk Knowledge Network. Again, I will be sending you these PDFs and the recordings, so you'll have these links at your disposal. The AKN, or the Autodesk Knowledge Network, again, has a lot more tutorials built into that that you can evaluate those at kind of your own pace, if you will. Our support group puts on monthly IQ webinars. They're usually once a month around lunchtime frame if you're on the East Coast. They have a series of topics that they talk about, so you can click that link and register if you're so inclined. Uh, they do bounce back between advisor and insight, so you can check the schedule and see what the topic of that month is. Tim and I are going to keep doing these quick start seminars. I do have one for cooling that I'll probably be touching on next week. It's going to be solely based around cooling, so we'll look at how to look at different functions of cooling. And then I believe we're going to be creating one around warpage and design of experiments in the near future. SimHub events, again, there's a lot of events posted there. And as well, we have a pretty substantial YouTube channel that has a lot more in-depth videos on how to look at different things like that. Tim and I do have some on-site training available. We've got a 3-day fundamental class that we can come on site and present, and it covers the topics listed there. And then we also have a 2-day advanced flow course that focuses around those particular topics. And then, as I mentioned, we have an advanced cool and warp that is 3 days that talks about core shift, fiber, cooling, and warpage in greater detail. If you need information on these, please feel free to respond to the email that I'll be sending you shortly, and I'll be sure to get you the course outlines and ballpark costs if you need that. That's about all I had for today. I'm going to go ahead and turn you loose. If you have any questions or questions, feel free to type them into the questions comment. Tim and I would be happy to answer them. I know that some of you had some detailed questions. I will take a stab at trying to give you additional information with my follow-up there. But if you don't have any other questions, feel free to roam about the countryside. I appreciate your time, and I will be sending you the recording as well as my slides for today. Tim, anything else to add? Still awake, Tim?
I am, if I can find my mute button. But anyways, no, great job, Mason.
Okay. Okay, I see a lot of people dropping off here, so my headset is also on its way out. So I'm going to go ahead and